All right, so we are going to use this problem to give an example of how to do a confidence interval for the difference in two means. We'll also use the same problem for a t-test for the difference. So first, problem says, patients with heart attack symptoms arrive in emergency rooms either by ambulance or self-transportation. When a patient arrives, the time of arrival is recorded, and the time the patient's first diagnostic treatment begins is also recorded. An administrator at a large hospital wants to determine whether or not the mean time for patients with heart attack symptoms differs according to the mode of transportation. A random sample of 150 patients with heart attack symptoms who had reported to the emergency room was selected. For each patient, the mode of transportation and wait time was recorded. Summary statistics for each mode of transportation are shown in the table below. So you have the sample size, 77 people via ambulance, 73 people via self. Mean wait time in minutes is 6.04 versus 8.30. And then the standard deviation of wait time is 4.30 versus 5.86. So we're going to go ahead and construct a confidence interval for the difference in these two means. All right, and if you saw the previous video, you know that I am going to not do this by hand because the formula for the standard deviation for that confidence interval is just horrendous. Now, whether or not you're supposed to use a confidence interval or perform a test would be pretty obvious in the problem. If you're wanting to perform a confidence interval, you would see something along the lines of, right, something like that. If it were a hypothesis test, you might see something along the lines of, that would be an example of what you would see if this were a significance test. For this example, we're going to stick with the confidence intervals. So, if you're having to perform the four-step process, you know the four-step process has four parts to it. So first, all right, there you go. So there's a perfectly good state for this. We would like to construct a 95% confidence interval for mu1 minus mu2, the difference between the mean wait time for ambulance riders versus self-drivers at a large hospital. You stated what it is you're going to do. You went ahead and included the parameters that you're going to use later on in the problem. You put at the level that you're going to do it at, and now you're good to go. So the conditions. Well, again, we got to know that it's random. Thankfully, it says in the problem that it is a random sample. Independence is mentioned as one of the conditions, but it's obvious that they're independent, so we don't really have to say that. That's not one of the things they look for. 10% rule, right? It's reasonable to assume that 150 heart attack patients is less than 10% of all heart attack patients that they would see. And the last, the large counts rule. This one, thankfully, both samples are over 30. You do have to make sure that the large counts rule is met for both the samples. And in this case, we have that, so we're good. We'll just leave that there. All right, now we have that set up. We can go ahead and actually construct the interval. So, go to my calculator, statistics, confidence intervals, and this is a two-sample t-interval. We know it's a t-interval because we do not know anything about the population standard deviation. You'd only use the z-interval in that very, very rare circumstance, and chances are you're not going to come across that in this unit or even on the AP test. We were not given the data, we were given the stats to work with, so now we just need to include our data. All right. So there's the data that we got from the table. X bar 1 and X bar 2 represent the two sample means. SX1 and SX2 represent the two sample standard deviations. And then, of course, our two sample sizes are here. Sizes are there. Now the question of whether or not to use pooled variance or not, or pooled standard deviation or not, if you know that the populations have the same standard deviation, have the same variance, then you can use pooled variance. Will you know that in practice? No. So you can almost never use this. However, ultimately it doesn't make too much of a difference in your calculations. This is what we would get. We have a lower bound of negative 3.79, or I'm sorry, I guess 3.8, negative 3.8, and an upper bound of negative 7.2. Now, what does that tell us? that tells us that we are 95% confident that the true difference in the means between the first population and the second population, the ambulance versus the self-drivers, is somewhere between negative 3.8 and negative 0.7, which means we are 95% confident that wait time for the first group was smaller than the wait time for the second group. There you go. Perfectly reasonable conclusion there. Like I said, there is that pooled version of it, but you won't really run into a situation in this class where you'll need to use that. You really only use the pooled variance form of a confidence interval or a t-test whenever you are assuming that the variance would be the same. Anyway, I hope this was helpful.